When we were talking about the atoms, one of the trouble that people have with the atoms is that they're so tiny and it's so hard to imagine the scale. That the size of the atoms are in size compared to an apple is the same scale as an apple is to the size of the earth. And that's a kind of a hard thing to take. And you have to go through all these things all the time. And people find these numbers inconceivable. And I do too. And the only thing you do is you just change your scale. I mean, you're just thinking of small balls, but you don't try to think of exactly how small they are too often, or you get kind of a bit nutty, all right? But in astronomy, you have the same thing in reverse, because the distances to these stars are so enormous. You know that light goes so fast that it only takes a few seconds to go to the moon and back, or it goes around the Earth 7.5 times in a second. And it goes for a year, 2 years, 3 years before it gets to the nearest other star that there is to us. But all our stars are the stars that are nearby in a great galaxy, a big mass of stars, which is called a galaxy, a group. But our galaxy is, what is it, something 100,000 light years, like 100,000 years. And then there's another patch of stars. It takes 1 million years for the light to get here, going at this enormous rate. And you just go crazy trying to make too real that distance. You have to do everything in proportion. It's easy to say the galaxies are little patches of stars, and they're 10 times as far apart as they are big. So that's an easy picture. No one gets it. But you just go to a different scale. That's easier. And once in a while, you try to come back to Earth scale to discuss the galaxies. But it's kind of hard. The number of stars that we see at night is only about 5,000. But the number of stars in our galaxy, the telescopes have shown when you improve the instrument. Oh, we look at a galaxy, we look at the stars, all the light that we see, the little tiny influence, spreads from the star over this enormous distance of 3 light years for the nearest star. On, this light from the star is spreading. The wavefronts are getting wider and wider, weaker and weaker, weaker and weaker, out into all of space, and finally the tiny fraction of it comes in 1 square, 1/8 of an inch, tiny little black hole, and does something to me, so I know it's there.